Hello, the internet. Welcome to Open Source Directions hosted by OpenTeams, the business-to-business marketplace for all of your open source services and support needs. Open Source Directions is the webinar that brings you all of the news about your favorite open source projects. My name is Henry Badgery, and I'm the growth marketer here at OpenTeams, and I'll be your host for this session. Joining me as the co-host is Tony.
Oh.
He's muted. I've unmuted you. Sorry, Tony. Wait. Oh, Tony, we've got you on mute, and I can't unmute you.
Oh, no.
Tony, okay, Jeff, how about you introduce yourself while we wait for... Oh, there we go. Tony's back. Oh, dear.
Yeah, something's going on.
Hey, Jeff. Okay, how about you? Yeah. Oh, he's muted.
Come back soon. Oh my God.
Tony, you there?
I am. I'm going to restart my computer and come back.
Okay, no worries. We'll just get Jeff. Jeff, do you want to introduce yourself? And then we'll get...
Yeah, sure. Hi, everyone. I'm Jeff Bezanson. I work on the Julia programming language, and I'm here in Cambridge, Massachusetts right now.
All right, and then we've got Katie.
Hi, everyone. I'm Katie Hyatt. I am a Julia contributor since 2015. I also work on a bunch of Julia packages, and I'm based in New York City, so apologies in advance for the ambulance sounds outside.
Well, thank you very much for introducing yourself. We'll wait till Tony, we'll keep going, and then Tony will join us. But hi, McGill. Hi, Mohammed. Before we get into the juicy details of Julia, an amazing programming language, we're going to give a few pull requests that both Katie and Jeff have been enjoying this week. So what pull requests have you found interesting? Jeff, what about you first?
Yeah, so, the new Apple hardware is upcoming, and it's something people are excited about. And a few people in the Julia world are on top of it right away, which I thought was, just pretty cool. The response time there was really good, and a couple people ordered some of the developer kits and have already started working on bringing everything up. And I think it basically works already, but there are a few details, a few rough edges. But I linked to a pull request there. Should I click it, or do you want to click it?
Well, we've got Brandon who just shared it in the chat. So if anyone wants to have a look at it, it's in the chat.
Okay.
Up there.
Okay, good. Yeah, so that's just one of the PRs getting Julia working on the new Apple ARM hardware.
Awesome. And Katie?
Yeah, so mine is pretty similar. So NVIDIA just released a new CUDA version, and one of the packages I work on a lot is CUDA.jl. So the creator of that package, Tim Bassard, has a really nice system set up where it automatically goes into the headers and creates wrappers. But then you have to make sure that it actually did that correctly, which could be a problem if, for example, the name of an enum changes. Mm-hmm. And a bunch of the tests broke, and a bunch of our existing wrapper code was wrong because also the order of some arguments changed. And figuring out what was not working. And then getting things to work again. And the turnaround time was pretty quick, considering CUDA 11 only became public like a week or so ago. So.
Okay, cool, awesome. Well, thank you very much for sharing. We're now going to get into the introduction section. We're just going to give everyone a little bit of context, make sure that you're up to speed with what Julia is. So Julia is a new programming language that combines the productivity of languages like R, Python, or MATLAB with the performance of C and Fortran. Julia provides a sophisticated compiler, distributed parallel execution, numerical accuracy, and an extensive library of fast mathematical functions. Very nice. It is being used by a number of universities around the world for both teaching and research. And in the area of business and businesses using it, there's a diverse range of businesses that use it in the fields of engineering, finance, e-commerce, and that's just to name a few. So one incredible thing is the number of users that are using Julia, and that is 10 million. That is just incredible and awesome.
Well, that's the number of downloads. I mean, that's not the. I wouldn't say it's the number of users. That's kind of the only counter we have. There's no way to know the number of users, but we know the download counter, and that's yeah.
Okay, awesome. So that's based off julialang.org and Docker Hub. So awesome. And Tony has joined us back here. Is everything working okay, Tony?
I hope
I
so.
hope so. Do you want to quickly introduce yourself?
Is it? Hi, I'm Tony Fast. I'm a data scientist and open source consultant at Quantsite. I'm based out of Atlanta, and yeah, I'm excited to be doing this Julia interview today.
Awesome. Very, very
Yeah,
nice.
so Julia's been around about 8 years at this point. I was just wondering how long we can still say it's a new language.
Yeah, I guess okay. So hey, it's not that new, but a lot
I mean,
newer
I
than
like being
Fortran
new.
or-
It's good. It's good to be new. It's exciting, but yeah, I'm just wondering how long we can keep that up.
I mean, is it like dog years
Yeah.
where each one is like 7 years of human time?
Yeah, I mean, it's much
do that.
newer. It's much newer than most languages people use, so it's true. But
Yeah, awesome. Okay, so why was this project started and what needed to fill?
I guess I can go first a little bit. So I did a PhD in computational physics. I've been doing scientific computing for a long time. And in that community, it's really common to have people doing their prototyping and data visualization in Python. And then they do their actual production code writing in C++ or sometimes Fortran. So C++ and Fortran are great languages, and so is Python. I don't want to make it sound like I think any of them is bad, but the situation where you have to know two different languages with pretty different internal structures is not necessarily great if what you want to do is write effective scientific code, because first you have to keep track of two code bases. And then also, if you want to communicate your code to other people, whether that's students who you're trying to train in your group or other scientists who maybe aren't as experienced with programming, it's really difficult because although, for example, C++ is a very powerful language, it's probably not the easiest thing to learn. So the other thing that's kind of not great about the scientific programming community is that we don't really have any sort of systematized way of imparting software engineering knowledge. So it's really common to find scientific code with no unit tests, no docs. If there are any kind of tests, they're often years out of date. The situation is really not very good. And so for me, the reason I switched to Julia was that I was able to write both my prototyping and production code in one language that I didn't really have to modify too much to be able to scale up to like many different distributed nodes or to be able to use the GPU, for example. And Julia promotes writing tests and docs from the get-go. It's very easy, like test support is built into the standard library, and so you don't have to install a bunch of extra packages to write unit tests. Similarly, it's really easy to measure code coverage. And Julia has really good first-class support for both like single node threaded parallelism and distributed parallelism and linear algebra, which was really important for me.
Awesome.
yeah, so that's that definitely describes the motivation. That's just the kind of thing we were thinking about when we set out to kind of solve this kind of problem. But what it comes down to, sort of at the programming language level, is kind of a tension between flexibility and efficiency, and that's something that's very difficult to get. In fact, it's really still an ongoing research topic in programming languages. No one really has like the perfect solution to it yet. But we wanted to kind of improve the combination of those that you could get, at least for some cases. For instance, and one example I like is like putting physical units in a program, like being able to label things as meters and seconds or something. And it's something that's come up a lot over time because it's kind of an obvious thing to do, and there have been famous bugs that happened because people, got confused units in their programs. So people wanted to do that, but and there've been many ideas about how to put that into languages, but it's kind of never really happened, right? Like how many programs have any of us seen in the real world that actually have units on things, right? It never seemed to really take off. But in Julia, it actually works really, really well. So there's a units library, and it just sort of composes with everything else very easily. So you can just make a matrix of unit quantities and just do linear algebra with it, and it just sort of works right away. And there's very little overhead. Sometimes there's no overhead, in fact, to doing that. Yet people have plugged units into, they use them a lot with the images libraries, and you can put them into differential equation solvers, for example, and everything just goes through and it just works. So it's kind of, I don't know how many people use it, but it definitely works for real this time.
That's super awesome. I guess what you're saying to me is that my comments about the units that my variable is, they don't count.
I'll take comments.
Compiler
Comments are
doesn't care
great.
about those.
I'll never say no to a comment.
Well, thank you. I was hoping that y'all could explain kind of the history behind the name and the logo.
Yeah,
of
everyone wants to
Julia.
know where the name is from. Understandably, there's not really a good answer. It just kind of sounds nice. It has some nice connotations like the Julia set, Gaston Julia. We also like to make up stories. Stefan likes to, every time someone asks, he tries to think of a different story. Like he said, he once told someone it's his middle name. It's just Stefan's middle name. Or it's I also like Julia Child is a good connection. She's also cooking up some programming languages in Cambridge. So there's not a really good answer to the name. The logo evolved out of the ASCII art kind of text banner in the REPL. That's actually one of the first things we did. I was like, okay, I know we need an interactive prompt for this, so we just made the REPL at first actually, and it just you just type something in and it just typed it back to you. There was no language, but that was the first thing we wrote. And so it was this ASCII banner that I kind of embellished a little bit, and I can't really do very much with that. I'm not a visual artist at all, so I just sort of added some more dots and some more colors. That's about all I could handle. And Stefan is like, "Oh, that doesn't look too bad, but we need a proper graphical version of this. It can't just be ASCII." So he made a SVG version of it where he picked a typeface and all of that and sort of turned it into more of a logo. So it kind of evolved out of very unskillful ASCII art and filtered through Stefan, making an SVG.
I love that story. I think that it seems to be quite the common thing is people just doing it themselves, and I love it. There's some crazy, funky logos out there. But on a different note, what are some of the alternative projects that are out there?
Yeah, so in science, like I said earlier, lots of people are using C++, Fortran, and Python libraries. MATLAB is really common too, especially in experimental science, because they have a really good suite of libraries for interfacing with your measurement devices or for doing PDE simulations, for example. AstroPy is a really big suite of really great software that probably the name implies astronomers use to do a lot of different simulations or analyze a lot of different astronomical observation data. Julia is also being used a lot for machine learning, actually, and I'm sure everybody listening to this is aware of the existence of TensorFlow and Keras.
For that, I guess following up there, what technology is Julia built on?
So a really big one is LLVM, the low-level virtual machine, which is kind of a common compiler infrastructure. The idea is, they implement backends for every hardware architecture, and languages all target LLVM, and then you get all those architectures for free. You get a bunch of reusable optimizations. And it started at the University of Illinois. I think not too long before we started working on Julia, around the same time, actually, maybe a couple years before we started, I believe. So it was kind of an exciting up-and-coming thing. And well, it still is, I guess. And it's used in a lot of Apple's tool chain. So it's used for Apple's default compilers, and it's used in the Swift compiler. So it's increasingly used, and it's we looked around for something to use to do native code generation, and we wanted to be able to compile in memory because we knew we needed a just-in-time compiler. And that just really seemed to be by far the best thing. It has a really good, thorough API. It has lots and lots of optimizations implemented. So I think it's just if you want something like that to target as a compiler, it's really just kind of far and away the best option. And it's generally really, really good. It's a great project. So that was a key strategic thing to kind of pick as a basis technology. And we also use libuv, which is the async IO library that Node.js uses. So that's another piece we have in there.
Okay, awesome. Well, it's a fantastic project and it's so popular. 10 million downloads is incredible, and the fact that Apple uses a lot of its devices, that is again just incredible. But it obviously started.
Apple uses LLVM. I don't know.
LLVM. Oh, LLVM. Okay,
they use LLVM.
Okay. So back to the origins of it, though. Who actually started the project?
So it was started by myself and Stefan Karpinski, Viral Shah, and Alan Edelman. I guess what happened was sort of Viral was the person initially who knew all of us, and we didn't know each other. And he had kind of separately talked to us, and I had, and Stefan had also at different times told him about ideas we had for programming languages. And then at some point he kind of said, "Wait a minute, you guys say a lot of the same things. You guys should talk to each other." So he sort of introduced all of us, and it just sort of clicked right away. We started this furious email thread that was just like went on and on, and so so we decided we wanted to do something like this. Just at that time, Viral and I were working at a startup company that was acquired, and so we were kind of at a transition point, and we wanted something else to do. So we thought about how we could really work on this and make this happen. And Alan Edelman was able to hire me at MIT to work on it full time, so it could get off the ground, and that's how it started. And Stefan and Viral contributed remotely, and then I worked with Alan.
That is a super cool origin story. So that leads me to ask, who's maintaining the project? Are all of the original people who created it still maintaining? And how is maintenance ongoing?
Yeah, everyone is still working on it. We're all still working on it very much. Now the number of contributors to the Julia language core repo on GitHub itself just recently crossed 1,000.
Wow.
So there's a lot of contributors now.
Yeah. And we have people from all over the world too, and not just academic people, like people who are in industry, people who are students, people who are just interested in the language for whatever reason. It's kind of cool to log on and see that lots of commits were made at 3 a.m. my time. And I know it's not just people who have a weird sleep schedule. And we also have people who are coming from like many different languages, in the sense of like human languages, not programming languages. So there's many different international communities that maintainers are from, which is really great. And we also now have a bunch of people who are employed by Julia Computing itself, which of course is also awesome because they can spend all their time working on Julia and making the tooling around it better.
That's awesome. That's fantastic. I know you briefly touched on it, but that's just like a really important point and something I'm really curious about is finding out more and just diving a bit more deeper into what kind of communities both the users and the contributors come from.
So at least from my perspective, there's a lot of variety. One thing that's really cool is that communities sometimes that wouldn't necessarily talk to each other end up interacting because of Julia. For example, like very early on after I started, in like late 2015 or early 2016, I remember I was talking to somebody who was a neuroscientist, and they were like, "This is really weird. I have this package, and all of a sudden these radio astronomers are just making all these pull requests against my package. I don't really understand why, but it's cool. I don't know anything about radio astronomy." And it turned out that like somehow there was some kind of like signal filtering algorithm that both of them used that neither group of people had any idea the other one was using. So this guy ended up talking to all these radio astronomers, and his work ended up benefiting them because they were like, okay, we're just going to make this signal processor package better. We're going to use it to look at stars. And it's pretty sweet because there's lots of that kind of cross-pollination also between people who are, for example, working in finance and then people who are working in applied math to simulate bridges or something. So there's people coming from many different fields of science and engineering and industry. And one thing I really like about the Julia community is that people are really smart, but they're also willing to not be the smartest person in the room. Like people are willing to learn from each other, which I think is really important to having a healthy open source community.
Oh, that's super. That cross-pollination is super inspiring. I feel like in the hallowed halls of academia, that stuff those people wouldn't cross paths very often.
Yeah, I think we've noticed a really noticeable effect in keeping everything in the same high-level language, and also having a lot of reusability and composability in the language. Like really, it has a social effect. It's the way it gets people kind of working together and on the same page like this. That's really been one of the most gratifying aspects of the whole project.
So it seems like y'all's software can affect a lot of different people in different languages, whether formal languages or programming languages. Are there any diversity inclusion efforts that help you guys bolster these kinds of contributions and community?
Yeah, definitely. I know, Katie, you can probably say something about that. I know we've done lots of. We have on the nonprofit side, we have often employed like a community manager who's in charge of those kinds of efforts. And we do a lot of outreach and connect to like campus groups and do workshops. And there's a diversity committee in JuliaCon, which is then a big part of the efforts. And I think Katie can probably say something about that.
Yeah. So we do have a diversity community dedicated to JuliaCon. Another thing that I think is really important to mention is that when talks are reviewed for JuliaCon, it's done in a double-blind way, so you don't see the name attached to the talk. This has been shown to be actually really important for having diverse speakers at a conference. One thing we also try to do is encourage people who wouldn't necessarily feel that they're like an expert on something to give a talk. This is also actually a really important way to encourage a more diverse speaker panel. Of course, there's many people who are experts in something and would give a great talk, but it is often the case that somebody who would be a really great speaker doesn't feel that they're able to give a good talk because they don't consider themselves an expert in something. And of course, JuliaCon only happens once a year, and we're still around for the other 360 something days of the year. So we do have channels for people to discuss diversity issues in the community. There's an active effort during the rest of the year to consider how our actions might affect diversity and inclusion and equity in the Julia community. It's definitely something we're continuing to work on. I don't think we want to rest in our laurels such as they are right now. It's definitely a process. So hopefully we'll be able to continue improving in the future.
That's awesome, and that's great. With 1,000 contributors too and growing, it's good to see you've got a structured approach to diversity and inclusion, because it is a prevalent problem in the world, but also particularly in open source. I just want to quickly remind everyone, please ask any questions in the chat. There's a little questions tab, and we'll then be getting to those questions later on. So just go to the right and pick out the questions tab and ask away. But now we're actually going to shift gears into what we call the project demo section, where we're going to be seeing some of the cool features of Julia and how it works. So while Jeff and Katie are getting set up, we'd like to take this opportunity to thank our sponsor, Quansight, for sponsoring this episode of Open Source Directions. Quansight, creating value from data. So when you're ready, Jeff and Katie, take it away.
So I can do a little demo of some multi-threading stuff, I think.
Okay. Awesome.
So, all right, let me do a screen share. Let's see, how do I do it?
Just little actions and then
enable screen sharing. There we go.
Here we are. Perfect.
Okay. So there is my Juno IDE.
Is that the ASCII art?
Yes, that's the banner down there. That predated the logo, actually. That banner came first, and then the logo is based on that.
Lovely.
So I have here a standard Mandelbrot set generator, but multi-threaded version, and so this is an example everyone does. It's a little bit old hat, but actually it's kind of cool in the context of multi-threading. So what I have here, so here's the function that just does a double loop to fill in an image with all of the escape time values. And what I've just added here is on the inner loop, which loops over the columns, over the Y values, I just put an @spawn. And so that just means, take this loop that's going to compute one column and just spawn that to run on some thread at some point. And then outside of that, I say sync, which means just to wait for all of those to finish. And then we can return the result. And so this is this new kind of spawn wait parallelism that's sort of similar to the Silk programming model, if anyone's heard of that, or it's also a little bit similar to Go routines in Go. So it's a really nice composable kind of elegant way to do multi-threading. And it works really well in this case because the thing about the Mandelbrot set is it's very, very unbalanced because all of the each of the points can take very, very different amounts of time to compute. So it's kind of very uneven. All right, so like one thing that doesn't work very well is just to like divide the image up into some blocks and compute those in parallel, because then the work can be very unbalanced. So here I'm doing it very, very fine grained. Each column is a separate parallel task. And so actually right now in the settings I have one thread here. So this is going to be the single threaded version, but I can just time that. It took about 2 seconds. Maybe I'll try it again. Around 2 seconds, and just to, not that it's directly relevant, but we can also look at the result. So the way I did that was I just did some scaling, and then I have this gray function from the images package that basically just converts a number into a gray tone. And then, so this is just an array of gray values actually. If we open this up and look at it, this shows kind of, I think it's really cool how images work in Julia here, because we can see it's actually just an array of gray values. So it's just a normal 2D array, but each element is basically like a little object here that represents a gray pixel. And of course, there are lots of other color types. There's an RGB one, there's RGB with alpha, and there's tons and tons of other color space types, of course. So it's sort of, so we know that this is basically an array of pixels, not just an array of numbers, so that when you try to display it, you get an image. But now let me try to increase the number of threads. So I have 4 cores on here, so I'll put that up to 4. But the thing that always happens here is, this is hard to demo on a video call because the video call itself uses a lot of compute power. So not all 4 cores are going to be completely available, but I'm game to try it and see what happens. So right now you actually have to restart to change the number of threads. I think we might improve that in the future, but for now, it's set on startup, so I do have to restart it to get the different number of threads. And we got the going. I hope it's faster. All right, so then it took 1 second. So for 4 cores with a video call going, I get a 2x speed up, which is not bad. So if you're willing to believe me, I tried this without the video running, and it went from 1.6 seconds to 0.4 seconds. So it was pretty much a 4x speed up. But with the video, I only get 2x, but there is a speed up there.
That's awesome.
So
yeah, you can do totally general multi-threading in Julia.
And this is a language feature.
Yeah.
Nice.
So this works with the whole language. It works with everything. It's integrated with I/O as well. So you can do, if you have to wait for an I/O event in one of these, it will get descheduled, and everything works.
Are the color types also language features too,
those are all in libraries. That's all in external libraries.
Cool.
Yeah, it does not have to be built in.
Awesome. Well, yeah, thank you very much for sharing that. Katie, do you want to share anything, or we move on?
I have a short GPU demo I can do if people are interested. Let me just clear.
Yeah, sounds great.
You guys are going to watch me live code, which is always a little exciting. Okay, the first trick is to find where my Windows subsystem for Linux is. There it is. Hello. Woo! All right, step 1 complete. Yeah, so I'm on a system that has a bunch of GPUs. So I'm just gonna launch Julia. Gonna activate the CUDA directory. So what this is gonna do is just say I want to use the specific environment I'm in. It's a little bit like Python virtual env. Don't take that analogy too far. And what we're gonna do is use CUDA and a package I really like called Unicode plots, which is what it sounds like. We're gonna make some, actually not that exciting plots in the terminal. So we're gonna wait a second while this, while some code is loaded. And basically the plan is that we're gonna make a random matrix on the GPU. We're gonna find its singular values and we're gonna plot those singular values. So if I wanna make a random matrix A, I can just say I want CUDA.rand, and this is gonna actually dispatch through the NVIDIA cuRand library, which is their GPU-enabled random number generator. Let's say I want to make this like 5,000 by 5. Typing is hard. And then the semicolon here just means it won't try and print it. So we're going to wait a second while this generates. The first time this gets run, it's a little slow, but it should be quicker. I'm going to make a second matrix that's going to be random normal distributed rather than random. I'm going to give it the inspired name B rather than A. It's also surprisingly slow. Annoying.
Got the video running too, Rory.
Oh yeah, that's true. Yeah, that might be why. So then what we're going to do is we're going to compute the singular values of these. And what's really nice about Julia is if you've ever written CUDA C code, you know that it's really powerful, but it's also extremely verbose. So the fact that we were able to write the wrappers in Julia means that we're able to just directly call Julia's linear algebra methods and have them dispatched through to the GPU, because Julia at runtime can detect, oh, this is a CU array, so it lives on the CUDA device, and I need to call the CUDA SVD values function, which is just like their implementation of LAPAC's GDSVD. So if I call SVD's A is equal to SVD val. Actually, the first thing I'm going to do is remember to turn off allowing scalar indexing, which can make CUDA code really slow. And then we're going to do SVD vals A is equal to SVD vals A. Oh, right. Forgot to use linear algebra. There we go. This is going to run. And then I will make SVD vals B. So I can just call this and it immediately knows like to do everything on the GPU. There's no memory transfer between host and device right now. This is done. Now I want to plot these guys. I can do that using Unicode plots. So I can say plot is equal to scatter plot. There's going to be 5,000 singular values because these guys are 5,000 by 5,000 arrays. I collect the singular values to move them back to the CPU. And I give this series a name, and it will be singular values of A. Okay. And there's a plot. It's kind of an ugly looking plot, actually. And the reason for that is that I'm trying to do this in Windows Subsystem for Linux, which is kind of sketchy Unicode support. So I'll just say, please only use ASCII characters. This should look a little bit better. Yeah, look at that. This isn't that exciting. There's only one dominant singular value, which isn't that surprising for this random matrix. And then we can put another plot on top. Again, 1 to 5,000. Moving back to the CPU memory, SVD values of B. The name is going to be singular values of B. And this bang character here means I'm going to be modifying the PLT object I generated earlier. So if I plot this, you can now see there's more singular values, and they're even labeled, and this is all in Unicode in the terminal. So this is actually very useful for me if I'm working remotely, like if I've SSH'd into another cluster or something, which may or may not actually even have X installed. Then I can make some simple exploratory plots in my terminal. just in ASCII or Unicode. And I'm able to just write some GPU functions without having to worry about passing pointers around, which is pretty nice. So Melissa in the chat says that she likes reading the bang as screaming the command. It's like very exciting. Scatterplot!
That does make your day more fun. It's very
It's
true.
very exciting. So that bang character it's not required. It's just usually a signal to the programmer that like, hey, this function is modifying. Be careful.
Ole Kruger, question mark, scatter plot?
Yeah, exactly. Scatter plot.
Plot?
And then if you get like one of the interro bangs, who knows what that does.
Yeah, so we have these various GPU functions, but also the GPU stuff in Julia can actually generate GPU code. So you can write like normal looking Julia code that loops over values and stuff, and it can compile that to GPU code. So we have both the like prefab array libraries as well as compiling custom code to GPU.
Awesome. Well, yeah, thank you very much for sharing that. It was great to see that. And now we're going to actually jump on to the roadmap section where we're going to be discussing. It's a fun little segment of this webinar, and we'll talk about where Julia is heading, what kind of future directions it's taking. So, Jeff and Katie, can you tell us a little bit more about what directions Julia is taking?
Yeah. So if you were looking really closely, you'd see in Katie's terminal it said version 1.5 RC1. So that's release candidate 1, and we're going to be through that process very soon. So version 1.5 is going to be released soon. It has a lot of stuff. There's going to be a blog post detailing it, but there's really a lot of improvements. So one thing that's exciting is we're moving to a new package and artifact server. So we've been moving towards making kind of Julia environments what we call totally reproducible. So like right now you can send someone a manifest file, and as long as you have that file, you can just exactly reproduce their environment with the exact same versions of everything. And we're also now extending that to data and binary artifacts in a persistent server. So it has the property that anything you downloaded once, you'll be able to download again in the future. So nothing ever changes or goes away behind your back. So anything you did before, you can do again somewhere else. So it's very cool. And we have this binary dependency system that sort of just works like magic. We can just serve out binaries, for any platform we support, and they're all pre-built. And it's really neat. And so we're more of that is coming online in 1.5, as well as a whole bunch of performance improvements. One thing you might have noticed during the demos is with the first time you do something in Julia, there's kind of like a little delay, pause where it's compiling things. So it compiles everything on demand. So these kind of compilation pauses the first time, that's very annoying. And sometimes they can be pretty long. Sometimes it's just a second or two. Sometimes it's like 10 seconds, which is really bad. So we've been working on that a lot, actually, and 1.5 is a lot better than 1.4 in that regard. And actually, I can tell you 1.6 is going to be even better than 1.5 because we've been focusing on that a lot. Multithreading is always improving. We're gradually working on reducing the overhead of scheduling overhead and all of that kind of thing. Squeezing out all the little long tail bugs. So it's starting to be used very widely, so that there's like a CSV parser in Julia that's 100% Julia, and it's multi-threaded, and it is now for some cases. There are a lot of cases, of course, but for some cases, it's pretty much the fastest thing out there, and very competitive with the other CSV parsers. Then, kind of just down the pipeline from that, we have the data frames package. Which has generally not had great performance. It's not that competitive with the more mature, data science data table implementations like Pandas and R's data frames. But we are now getting there. So that's one of the focuses. The people are now seriously working on the performance of the Julia data frames, and it's starting to get competitive. And we're still working on that, and hopefully we'll at least come to par with the other stuff out there. Another big focus is differentiable programming, automatic differentiation. So we have this package Zygote, in Julia that's pretty much works completely. So it's a really powerful auto diff system, and we do everything with like generality. It's our big thing. So it has to work with absolutely everything. You can differentiate arbitrary programs. Someone did a ray tracer, for example. So there's a differentiable ray tracer written in Julia. So you can so you can play with reverse rendering kinds of problems. So that all is really cool. But it has some limitations, so I think there's some performance issues sometimes if you do higher order derivatives, I think. That doesn't work that well yet, and we're working on that. So that's going to be fixed, I think, fairly soon. And then also there's Flux.jl, which is an ML framework, a machine learning framework. And we're also sort of constantly working on improving the performance of that, and bringing that up to par or better than all the competing things out there. So the machine learning competition is fierce out there. So it's that's something we're always working on.
Awesome. Okay, did you have anything to share about the roadmap or anything you've been working on?
Yeah, I mean, so obviously we're still working on GPU stuff. One big goal for that is to get single node multi-GPU working well. This is something that's really important in HPC, but also for machine learning. For example, Flux currently does not support multi-GPU training, which is a problem because PyTorch does have that functionality, and it's just important to be able to do large data sets. One thing I think is really positive in general about Julia is we now have more people who are just using the language to build things rather than becoming contributors, which is good because it means you don't have to become a contributor and be constantly fixing bugs to use the language. Like, you don't actually have to care about how Git rebase works to be able to do cool things, which I think is good. But if you are interested in Git rebasing, you can definitely keep doing that.
Okay, cool. Yeah, very much for sharing. That's exciting to hear where the project's heading. We'll now answer a few of the questions that were asked throughout this webinar. So I thought we'd kick it off with Miguel Raz's question. He has asked, Jeff, what do you think is the coolest project that should be built on Julia but hasn't yet?
That's a tough one, but I think I'm going to go with operating system. So it's Julia is definitely not designed for writing an operating system. It's not. So it would be quite a bit of work and kind of rethinking to sort of reorient it towards that. But I think a Julia operating system would be really interesting. Basically, entirely, all of the isolation would be essentially like language and type system enforced. I have some ideas about that, but yeah, I think that would be very cool. But that's a really hard long-term project. But he said coolest, so this is a superlative.
Oh, Tony, I think we got you muted. There you go. I've unmuted you. There you go.
Thank you. Yeah, Melissa has a question that's not about the coolest, but what packages are high priority right now in increasing adoption of Julia, like outside of the academic settings?
I think for us, the biggest, most important ones are definitely the machine learning stack and also data science. That's what people, I get the strong impression people from non-academic settings are coming to Julia because they hear it's really good for these things. But there's definitely still some rough edges to all these packages that need to be smoothed out. One thing that we definitely need more of and would actually be really great for new contributors to get involved in is writing tutorials. So like Flux has a model zoo where they implement some famous machine learning papers and stuff like that. That's something that for newbies can be great to get involved in. Or writing cool sort of like towards data science-like articles using the Julia data science stack.
Awesome.
Cool.
Awesome.
You got Melissa stoked.
Yeah, she said, yeah, documentation. We need more documentation everywhere. So another question from Miguel. Catherine, how have you found working with GPUs in a distributed setting on Julia?
That's a really good question. So I think the best way to say it is that it's not any worse than doing it in another language. So basically, there's a couple ways you can do this. There's like CUDA plus MPI, and then there's NVIDIA's NCCL. So if you don't know what all these acronyms mean, don't worry, it's not that important. But basically, the idea is to split up the problem among many GPUs, which are themselves split up among many nodes. And then you have to have some way for the nodes to talk to each other. If they're doing it through MPI, everything has to go through the CPU memory first. So the GPU first offloads its memory through the PCIe bus, and then that goes through InfiniBand or whatever. Or there's now NCCL where the GPUs communicate directly without involving the PCIe bus, which is good because that bus is really slow. But in terms of just like how easy it is to write code that does any of this, unless your code is like the world's most obvious MapReduce, it's not that easy. Which is not that surprising. I mean, distributed programming is really hard. That. If it was easy, everybody would be doing it. This is sounds of both everybody.
Winky finger.
So I think there's definitely a lot of opportunity for Julia to make this easier. And that's definitely something I'm interested in pursuing in like the next couple of years, trying to make this more accessible to people.
Well, cool. Thank you so much for that. It looks like, Miguel, that Jeff has shared the code from the demo. So we'll follow up with Miguel's other question, which is, how well do you think Julia's multi-threading can handle lightweight network I/O versus Go's multi-threading?
So we haven't done a lot of thorough benchmarking of that kind of thing, so I'm not totally sure. I know, Go has obviously put a huge amount of effort into that because that is their, number one use case. So they are probably benchmarking that and fine-tuning that all day, every day. So it would be hard to believe we did better than them. And I know also Go has, a huge library of network protocols implemented and all of that, which we don't have all of. We have HTTP, but they have everything. Mm-hmm. But I think, from a very high level, I think it's roughly as good. Like there's probably not, massive differences, but I'm sure they're probably better at that. But I think it's like roughly as good. We do this, like our package server is written in Julia, for instance, using our async IO stuff. So, it works. But yeah, I don't have thorough benchmarks, but I suspect it's like roughly okay.
Awesome. Yeah, thank you very much for sharing, and thanks everyone for your questions. We do appreciate that. We're now going to move on to our world famous rant and rave section, where each one of us is going to get a 15-second soapbox to either rant or rave about whatever topic they desire. So I think, Jeff, we'll start off with you.
Well, 15 seconds is not enough. I mean, come on. But
make it longer than 15. We got time.
I don't know. There's a lot of stuff that doesn't work. There's so much stuff that's supposed to work but just doesn't work. Like there are things we've never gotten working. Like we try to intercept Stack Overflows and give a nice error instead of just crashing, and we have that working fine on Linux and Windows and FreeBSD, and we cannot get it working on Mac OS. It just, no matter what, it is always seg faults. Maybe sometimes it works, but not very often. And we just can't. It doesn't work. There's a signal you're supposed to be able to handle and whatever, and we've tried all of that, but it just doesn't work. And and there's just so much stuff like that. There's just so much stuff that doesn't work. I don't even know where to start.
Fair enough. Well, there's always something to work on then, I guess. Katie, what about you?
Yeah, so I think all my responses have been GPU based. You guys can see I'm like clearly obsessed. But my big one is I've been wanting to use CUDA from Windows Subsystem for Linux for years because this is actually also a two-part rant because as far as I'm aware, the build process for Julia on Windows is like still horrendous. It involves MinGW. That's like probably all anybody needs to hear. And yeah, I don't like the Windows development environment, so that's cool. The nice thing is that with WSL2, it's finally going to be possible. So it wasn't possible before to do this because basically WSL would not play nicely with the graphics driver, and that's going to change. I know, shocking, Linux not playing nicely with proprietary graphics drivers, who could have expected. So now that it's finally happening, I will be able to seamlessly switch from playing Crusader Kings 2 to developing graphics. So.
Very nice. And Tony, how about you? What's your rant or rave?
Well, Katie might be the coolest person I've met in a very long time, but I'm going to piggyback off of Jeff a little bit. Like, everything sucks and everything's broken, but there's some really good stuff in there, and right now it's a tough time, And especially in this open source world, being positive over negative and inclusive over exclusive is really going to help us get through a lot of this work.
Yeah, and the flip side of that is it's really impressive how much stuff everyone is able to do and get working in spite of everything not working. So that's promising.
Exactly. That's why I have faith in humanity. We're going to keep moving forward. Well, mine's actually a rant, and it's not a great topic, but I'm not sure how many of you know about this. But Australia was looking good in terms of coronavirus. Like, I think I was looking, it was like 13 cases a day, 6 cases a day at one point. And then in Victoria, there were a few security guards working in that. So essentially, the government would pay for you to quarantine in a hotel for 2 weeks if you arrived from overseas. And security guards couldn't keep it in their pants and were sleeping with people who coming in from overseas who had coronavirus. And now it's spread all over Australia, and we've going into a second wave because of that. And it kills me. And it's just
that's extraordinary.
One job, and now
everyone wants to be more like America.
Everyone, we're just trying to catch up, all right? Well, thanks everyone for watching, and thank you very much for joining us, Jeff and Katie, and also Tony. Thank you for joining. That's all we have time for today, sadly, but you can find us on Twitter at OpenTeams Inc. and at Quansite AI. Jeff and Katie, where can people find you and more about info about Julia?
Sure, go ahead.
Well, check out julialang.org. That's the website. Lots of links there. I am just my first name, last name, Jeff Bezanson, on GitHub, and the Julia Slack, Julia Discourse Forum. Yeah.
I'm on GitHub as @KSHyatt, on Twitter as @KSlimes, and I'm also on the Julia Slack a lot. When quarantine started, I was live coding a lot on Twitch. I kind of fell off the wagon on that, but I want to get back into it. So check out twitch.com/KSlimes for hopefully soon to be revived Julia live coding.
Awesome. Well, yeah, thank you very much again. If you like what you saw today, then please go to our YouTube channel and like and subscribe to see more of this kind of content. We really do appreciate it, and it really does help us. So we look forward for all of you joining us next episode. You'll be joining us in a lesson on NB Grader. So thanks very much, everyone.
Thank you.
Thank you all. Bye.
Bye.